All right, so welcome to week 3 of distance learning. And if you've been following along, so we went through section 11.1, 2, and 3, finding areas of shapes. Then we took a break for trig, for special right, because we need them going forward. All right, so we're back to 11.4, and we're going to use some of those ideas going forward. So here we go, regular polygons and composite figures. So the big thing here is if you're going to find the area of a regular polygon, right? So there is a special formula which we can use, which is right here. Right? The area equals 1/2 the apothem times the perimeter. Right? So just to go over the basic parts of this, the apothem is the distance from the center of the polygon to the midpoint of a side. So in this pentagon here, it's segment AP. Right? That is the apothem length. Then there's the perimeter of the regular figure, which from this pentagon, if you have one side, multiply that by 5, you'll get your perimeter. Right, so the area of the figure is 1/2 the apothem times perimeter. Right, so let's apply this as we go a little bit forward. So of course there are some nice notes you can take a look through, but it'll help set you up for the first 3 problems of your work. All right, so number 1. So with this, these are regular polygons. So with that, by definition, it's regular. So these are equilateral and equiangular. All right, so if this one side, sorry, I marked this up already, but this 14 meters is this 14 meters is this 14 meters. So really, you know the perimeter already. You've got the 1/2. We just need the apothem. All right, so finding the apothem, if I know this length to the center, that would be good. So really, if this is 14, we know the bottom half is 7, right, which that's here. So the apothem, which we'll have to find, is this length, but we need to find an angle first. So if I go all the way around this figure, that's 360 degrees, and I drew these lines in, so this line, right, with this makes one triangle. This line with this makes another triangle, and we've got a third triangle. So if I did 360 divided by 3, we get 120, but this line, the apothem, would break that up into 2 more triangles, so therefore that's a 60. Right? 120 for the whole angle. Each half would be 60. So that's where I get the 60 from. And notice that 60 is actually a special right triangle angle. Right? This triangle would be a 30, 60, 90. So if you take your 7 meters from before, divide by radical 3, and when you rationalize it, you get 7 radical 3 over 3. That is your apothem. So really, once you have that, we have everything we need to find the actual area. So 1/2 of the apothem, which is 7 radical 3 over 3, times the perimeter, which would be 14 by 3 there, which is, what, 56? So 1/2 times 7 radical 3 over 3 times 56. All right, so actually 52. 7 by 6 should be 42. Sorry, 42 there. All right, so then find the 1/2 AP, then you're good. All right, so then the other part of number 2, same thing. If I divide this up, you've got 5 separate triangles. Right, you've got one side length, which is 10, so you know the perimeter of 50. So perimeter is good. Half is good. We need the apothem, of course. So I broke this triangle out here. So here's your 5. Here's the apothem. But we need this angle up here, which, if I did 360 divided by each of these 5 angles, it's up top here. Right, so let me see. I can scroll up a little bit. Is 360 degrees divided by 5, which is 72. So each one of these main central angles would be 72. But if I divided by 2, we'd get 36. Right, so 36 is good, but it's not a special right triangle angle. Right, we need 45, 45, 90, or 30, 60, 90, not 36. So because we have 36, we need to set up a trig relationship. So, right, so 36, we've got the opposite and the adjacent, so there's tangent. So tangent of 36 equals 5 over x. Remember to put tangent of 36 over 1 and then cross multiply. You'll find out what that apothem length is. But once you have the apothem, right? That's the a, lowercase a. You've got the perimeter of 50. Plug it into your formula and you can find the area. All right, so that's a trig-based regular polygon. So the last one I'll walk you through is this square. And you only had the one triangle here, but I marked it up again. So each one of these central angles will be 90, right? 360, the whole figure, divided by 1, 2, 3, 4 gives you 90. But half of this will be 45. That's how I get that. Half of this side is 7.5. And because now we have a 45, 45, 90, it's basically a right isosceles. So we've got 7.5 here, and your apothem is now 7.5. So plug into the 1/2 AP from all the way over here. 1/2 of 7.5 times your perimeter, which would be 60, and then you can solve problem number 3. All right, so use those going forward and look for what you're solving. In this problem, you're given the apothem. You have to find the perimeter, so use that accordingly. Right, use special right or trig. Same thing here. If you've got 10 for the side, you've got a 5 for this piece, but you have to find the apothem. And number 5. Whoa, that's weird. 6 and 5, sorry. Because for number 5 over here, in this triangle, 7.5 is your apothem, and hey, you have 10.9, so you can find out the actual perimeter. Right, so use the pieces that are given to help you find out what's missing and solve for the area accordingly. All right, thanks guys. Let me know if you have any questions, and I will talk to you soon. Bye.